welcome to another Tech Talk session. Today we are going to talk about micro frontend. Okay, so before talking about micro frontends, let's look at the common architecture, system architectural examples. So how currently we do things, right? So when we look at the back end, uh, we may have multiple services doing various business related logic. So we normally call these services as microservices. So they may communicate with each other as well through indirect communication channels. So yeah, so this is known as microservices. So basically, these individual services are scoped around business capabilities, and usually this each and every service is being developed by an autonomous teams. So that means basically they can be responsible about the architecture, the internal decisions regarding how the system, the application should look like. And normally these these teams, they have their own development and deployment cycles, and these are loosely coupled. And also, these services can be technology independent. That means while several services can be developed using .NET, and some can be developed using Node. Some can even be using Java. So this is the back end. What about the front end? So what we normally have is a one monolithic front-end application, which is communicating with the back-end services, uh, maybe through an orchestration layer as well, but if not directly through to the individual services cannot be the case. So it's a monolithic application. So all the areas are implemented in one web application. So if it has to be if a certain feature is developed related to one particular area, still, if there are front-end changes, the whole application has to be deployed. So this works, but there are some issues. So one thing is, since it's a very large application, it automatically leads to larger development and deployment cycles as well. Okay. So what about these applications? We know Microsoft Azure. So it provides a lot of cloud solutions, from platform as a service project solutions to VMs, Active Directory support, various things are there. And what about Azure DevOps? We usually interact with the Azure DevOps, and we know we can even write plugins for Azure DevOps as well. So they have repositories, project management, CI/CD pipelines. So a lot of things are there. So what if so do you think that for one change, change in one particular area, uh, do they have to deploy the whole application? So how feasible it is to deploy the whole Azure portal to introduce a new feature? So that's the problem that we face with the current front-end architecture. So the solution is micro frontends. So the basic idea is you have front-end modules which are talking to back-end service modules. We can call them microservices. So for each and every microservice, we can have another module, micro frontend, sitting in the front. So the application is not one single front-end solution. It's a distributed front-end solution. So this is the kind of architecture that we talk in micro front-end architecture. So obviously, we can't have users going into multiple endpoint. So we definitely need to have some kind of a bootstrapping layer to all these things bundled together. So it can be a simple HTML file or it can be something else. But the basic idea is you have to have a bootstrapping layer and individual components, individual areas of the application can be separately and probably they can be deployed as well, deployed separately as well. So there are several approaches to implementing this. So let's look at all these different approaches that we can take to implement a Microsoft front-end solution. So one thing is URL integration. So this is the simplest form. You have a dashboard and a navigation panel, and each and every URL can point to a subdomain or some kind of a link, and the user is coming to the actual the portal or the bootstrapping layer is getting that user is getting routed to different areas of the application when you click the URL link URL. So a good example is our own Givio portal, where we have the portal landing page, and there are. Can you guys hear me properly?
Yes, we can, but it feels like there's some sort of internet quality degrade, but we can hear you clearly.
I think it's raining and okay. So coming back to the presentation. So one good example for this is our Givio portal. We all know that we have a landing page. There we have URLs for different areas. So it can be considered as the simplest form of micro frontend architecture. So these individual applications can be developed by autonomous teams, and we can use different technologies. So independent development cycles, deployment cycles can be there. And also, as I said, we can obviously use different technologies for individual applications. But there are some problems. Uh,
So Chamika, so in
hmm,
these kinds of cases, most probably these different, so they will be different sites altogether, right? Hosted under probably
yes,
different domains, different URLs.
yeah, yes. Probably, if you want to give the same kind of an experience, you can have hosted these different applications in different subdomains or under the same main domain.
Mm-hmm.
But
Yes, okay.
but still, yeah, they are completely different applications.
Okay.
So the issue is there can be inconsistent UI and UX experiences. If we compare, if you look at our own example, the UI in our leave system and the UI in our recruit system, they are somewhat different. So inconsistencies in UI and UX is something that we can expect. We go down with go implement this in implement microservices in this way. But this is also a viable solution. It might work for certain cases. So another problem is sharing content. Now in our dashboard we don't have content coming from multiple applications. But what if our solution require us to show content in our dashboard? It doesn't need to be dashboard, only dashboard. It can be any other page as well. But if you want to show content coming from multiple content in the same page, so in fact dashboards are a sort of areas where the context are getting mixed up. So you have widgets, coming from different areas. So this approach fails in that area. In the same time, what if you want to interact between these different components? That means what I mean by that is if you click on, if you select a list from one component, if you want that to be reflected in another component coming from a different micro front end, it's a bit hard to implement something like that using this architecture, this method. So another approach is to implement micro front end is to use simple iframe. So you can use iframe to integrate different areas of the application into the same page. So still these applications will be hosted in different independently. So you have all the advantages or the possibilities that you had with the previous method, but still inconsistencies in UI and UX will be there, and also the limitations in interacting among different components will be there. The only thing is somehow you can show content from different micro contents in the same page using iframes. So this is also a suitable solution for certain requirements. You don't need to make it too complicated if this solves your issue problem. So if you want something really advanced, you have to go away from these URL integrations and iframe integrations, and you have to use some other special mechanics. So one option is to go with server-side integration. So that is, you develop these applications separately. When you deploy as part of the CI/CD pipeline, everything is getting merged and deployed as a single application. So the problem is, so you can get everything. It will look as it will be actually a single application for the end user. But the problem would be if you want to do a change to one particular area, you have to deploy the whole thing, because the bundling up, the integration happens in the server side. So it's part of the build pipeline. So even if you change something, you have to deploy the whole application. So if it is very big, the same problem comes back. So you have to deploy the whole application. So one thing that we would like to do is not to do that. Like, we would like to deploy only the area that we have changed, so that we only need to test that area, and the impact that it can have on the actual application is minimal. So the integration has to happen. Yeah, so that's it. So the solution to that is client-side integration. The browser has to integrate all. So there are also two options to this. One option is to use web components. Web components is an HTML5 standard, a new HTML standard, where you can have custom components defined. This works, but there are some limitations. One thing is, it is not just showing data. You have to listen to certain other components. You have to, it's data driven. If you click on one thing, the other one has to update. So simple web components is not sufficient to implement something really complicated. So that's where these web components fail. And also, if you take some browsers like Safari, they have some limited browser capabilities compared to other applications, browsers. So web components, support for web components is not fully there. So it is a limitation with this approach. So the other thing is to use a JavaScript or a certain framework which is built targeting this exact thing, exact requirement, so that they look they do it does the heavy lifting. So all the interactions, all the integrations, all the intercomponent interaction, everything has to be done. Will be done using this framework. So this approach works well because now the bootstrapping layer that I talked about, it's sort of behave as a which actually loads all the dependencies. Let's say you are building application using React. So if all the microservices are built using React, you don't need to integrate React to individual components. You can have React as a dependency of the app shell. So at the same time, all the common themes, CSS themes, libraries, everything can be attached to that bootstrapping layer. Consistent UI experience throughout the system. And using since you are using a JavaScript-based solution, a plugin for that, to integrate all the communication between each and every micro frontend is supported. So this is the most suitable way of doing. So if you look at this architecture a little bit thoroughly, so the application shell has to do a lot of things. Apart from just being an HTML index.html page, it has to load all the common dependencies, and also it has to load the common CSS and other styling related stuff as well. And when we are doing deployments, we don't want to disturb the other modules and the app shell. So the preferred way would be to deploy these individual micro frontends to a different module repository. It can be anything. It can be a blob storage. It even can be your Google Drive as well. Given that you have configured things properly, it can be anything. It has to be a storage location. So these modules will be very thin. They will not carry any framework related content. Only the information, or only the content that is related to that particular module will get deployed into this module repository. And the app shell has to load these modules. So it has to know where the modules are stored and which modules has to be called for which page and everything. So it has to use a module registry. So this simply can be a JSON file. You can have the JSON file inside the application shell as well. Then the problem would be if you are deploying a newer version or a new micro frontend altogether, you have to go and update that registry. So that means basically you have to deploy the app shell again. So a much more better solution would be to have a separate module registry. It can be a Azure function. It can be an Azure function where it gives the location of the modules and all the information. So the application shell, what it does is when it receive the request, it will communicate with the module registry and get to know where the modules are stored, and then it will load the appropriate modules with the information that it gets from the registry. So this is the basic idea of a modern micro-frontend architecture. So if we talk a little bit further about this, you can do things like all the common things like notification, displaying notifications, even authentication, and all these common stuff can also be done by the application shell. Okay, so with all these discussions, we are trying to bring certain already existing well-known backend architectural concepts to the front end. So microservices, in microservices we do these things. With microservices we use, there's one particular concept. It doesn't need to be with microservices, but it goes hand in hand with microservices. All these independent and loosely coupled structure, all and these other concepts also support these. Also, when we talk about these other concepts, what is the other technology or the architectural design that we talked here along with microservices? It is serverless, right? If we take Azure functions, for example, you have individually deployed Azure functions, and they have container runtime with them. It's up to the runtime provider or the cloud solution to provide the runtime and all the infrastructure level support. So when you deploy a microservice, you don't deploy all the dependencies and all the framework related stuff. You are just deploying the implementations related to your the build output related to the implementation, the business implementation. So the same thing for micro-frontend. Can someone tell me what would be the counterpart of serverless for back? If it is serverless in the back end, what would be the similar thing in the front end?
The application shell.
Application shell is the it's infrastructure layer.
Yes. So that does the job of this serverless platforms, right? Oh, probably I didn't understand what you're getting at. Probably. I mean, that's how I thought. Like the app shell is the one which sort of replaces that serverless
architecture. Yes. The concept is actually SITELESS. I mean, it's the same. It's correct. So the app shell has to, look after all the frameworks, dependencies, and everything. If you look at microservices, micro frontends, they are chunks of web application. They can't run without app shell. Similar to the Azure functions, similar to how Azure functions work. You can't execute Azure functions without the infrastructure layer, right? So it can be Azure functions in Azure, it can be Lambda functions in AWS, so the same concept. So the thing is, so you do not need to deploy the whole thing when you deploy a micro frontend. That is the target that we try to achieve. So if we compare these concepts, in order to implement something similar for the front-end applications, what are the things that we need? Of course, we have to first develop these things. So standard IDE support has to be there. So it can be VS Code, it can be Visual Studio, any other. You should be able to implement these chunks of web application, which cannot be executed directly in your development environment. So you should be able to write code, and in the same time you should be able to debug and run them probably via an emulator. So that is the same thing that we do with Azure Functions as well. So we have to have the emulator installed. So when we do micro-frontends in this way, to load the app shell and to run it, we may need to have an emulator or something similar. And similar to the serverless architecture, we can deploy individual micro frontends without the runtime, as I explained. And when you deploy these independent deployed micro frontends, should get instantly available for the final application. So we talked about a lot of the concepts. So let's look at this implementations and to see how it works and all. So I have 3 projects. Let me show this to you. So I have the app shell. App shell is the one, as I said, it's the one which is responsible for loading all the dependencies and loading all the site-wide styling and everything. And I have 2 micro frontends, both developed using React. So one is a detailed view and one is a list view. And these 2 micro frontends will get rendered in the same page, and in the same time they will interact. They will be interacting with each other. So if we go and look at the project.json files of the app shell, you can see if you go to the dependencies section, you can see React as a dependency. So this is what I meant by loading all the common dependencies into the app shell. Even if you go to the index.html, you can see all this custom styling and Bootstrap or any other framework, CSS framework. I mean, you can add into this page. It's very simple. You just need to define all the site-wide dependencies in this shell project. So it can be a different repository as well, and it can be developed and maintained by a separate team.
So the app shell project source code does not contain any micro components, right? They are in other projects, other source repositories even.
Yes, yes. So the components, yeah. So if you go to the list, one of the other micro frontend. Now this is one micro frontend, right? So if you go to the dependencies, as I said, this is you have dependencies to in order to support development experience, but nothing is being deployed. There are no dependencies for the micro frontend, this particular micro frontend. But if you have something like which is only used by this particular frontend, micro frontend, you can have that, of course. But common dependencies, you don't need to add. So if you go to a component, so this is React. Basic React component. You, by the way, you can have multiple components. You don't break micro frontends per component, right? You can have multiple components. It's similar to how you do with microservices. So in microservices, you define a microservice for a particular business area. You call that bounded context. So one particular business area. For example, if you take a banking solution, you may have several microservices to cater for several areas, right? Several different areas. For FD, for savings, for leasing, for gold loan, you may have different micro frontends as microservices. In the same way, you can have micro frontends as well. So you can have multiple components in a micro frontend. So basically, you can treat one microservice or micro frontend as an independent application. For the demo, for this demo, I have only one component for each of the two micro frontend. So this is a React component which displays all uh, the countries. I have a list of countries, so it is just displaying all the countries here. So if I go to the detail view, it is the same thing, right? It is the same thing. You have no dependencies. So you have the detail view. So right. Okay. So let's see this in action. So I have already deployed this to Azure. So you can see these two components are getting loaded into the same page. Not only that, they are getting rendered in the same page. If I click one of the countries here, you can see that the other component, now this component, the detail view is getting loaded from a completely different project, right? It is getting updated. So the event-based data parsing and communication is supported. So it is the framework or the app shell which is doing all the communication. So it is providing all the, or which is facilitating for the inter front-end, inter-micro front-end communication. So you can do it. So I said you should be able to communicate and render these components in the same page. At the same time, one of the most important reasons to use microservices or even micro frontends is to be able to deploy these micro frontends independently, right? So let's try that out. Let's add a country to this list, right? So let's go to the country list related micro frontend. So let's add this. Let's add England to the list. So we don't have England here. Let's add it. And let's save it and let's publish this. So I'm only publishing this particular micro frontend, not the whole application, right? So it's published. Now let's go to the distribution folder. So you can see on very small stuff are there. You don't React and any other things are not getting deployed. So let's go to the application and refresh and see how it works. So as you can see, England is there. So that means it has been updated. The new version is there, and it is automatically interacting with the existing application as well. So that's how microservices work and how this is a very simple demo, simple example. Let's do that. Let's do another example. Now, if we go to this is the list view. If we go to the detail view and let's show the let's show a larger view of the flag, country's flag. Very simple. Let's deploy that. This time I'm deploying the detail view. totally fitting well. So for this particular demo, I choose this framework called Pyral. So there are some other micro front-end frameworks as well. So it's deployed, I guess. So let's go and refresh this. So we select country, you can see the country. So the newer version of that particular micro front-end is available. So you can deploy what you need to deploy. You don't need to deploy the whole thing. And the app shell is not getting deployed as well, because in this particular demo, I'm not using a JSON file. I'm actually using a dedicated module registry. I'm referring this application. If you go to the implementation, so this pilot tool, they provide this kind of a solution for development purposes. You can implement or install your own version as well. It's very simple, but I'm just using the same thing. So this we can have something similar implemented and hosted in as Azure function, for example. But this does is it just exposes the available front end. So when you do a deployment of a micro front end, the app shell is not getting restarted. So in the so if you go to the actual application root folder, www root folder, nothing is getting deployed there. Maybe you are deploying the front end to a blob storage, as I said. So the application is not going offline even during the deployment stage. So this is implementation. Any questions regarding? Yeah, we'll continue with the presentation. So if there are any questions, we can ask later. So, so you saw the demonstration, and I also explained to you about the concept and the thinking behind the front-end micro front-end architecture. So where does this leave us in terms of the development approach that we need to take? So if we take one micro front-end, most probably it is also getting back by a microservice. So if we consider this combination, it can be considered as a separate independent application. So there can be more of such application instances. So you can have independent teams to look after one of these sections. So that means basically one team can develop the microservice and the corresponding front-end as well. So you can have full stack development team to look after this business implementation. That doesn't mean that you have to have dedicated team for each and every project, each and every microservice or micro front-end. If if you want, you can have one team looking after two microservices or micro front-ends as well. The other thing is the application shell. Usually this would be just a UI project, or in certain situations, it can be a little bit more than that as well. If you want to handle authentication or certain other things, some common stuff, this may itself has a backend as well. It depends on the approach that you take. So you can have a dedicated team. It can be a front-end team, or it even can be a full stack team as well. So you can have a separate team which is responsible for the application shell. Or else you can ask one of the other teams to look after the application shell as well. What you should not do is to develop the micro front-end in one team and develop the microservice in another team. can cause certain problems, but this is the most natural way of doing things. Right. Okay. That's the end of the presentation. So if we talk about what we learned, one thing that I want to tell is monoliths are not bad. After listening to this, if you think that for the next project that you have to use micro-frontends, it may not be the ideal solution. For a simple project, monoliths work well. I mean, you have everything in the same code repository, everything in the same solution. It's easier to maintain for a small project. Only when that things go out of hand, when the project becomes very large for you to maintain and within one team, then only you should look into these kinds of approaches. So don't think that this is a bullet for everything. This has its own problems, similar to the problems that we have with microservices. So the one thing is the front-end application itself is going to be a distributed application. So with distributed applications, the issue is what could go wrong in a usual application, a normal application, are bound to go wrong with distributed applications. The communications and everything is much more complicated. So you have to keep that in mind when you are doing these things. This is a personal opinion thing. If you are considering doing microservices for your backend, then that is a good indication to consider using micro-frontends for a front-end application. So that will enable you to get the most out of your microservices architecture, because otherwise, if you do a change in your microservice, and as part of that implementation, if you have to do a change for your web application, that means basically you have to deploy the whole thing, the whole web application at least. That means you have to test everything. So when you have micro frontend, and especially a micro frontend per microservice, if that can be done, then you just need to worry about getting that particular thing deployed. Only then it will save a lot of time and effort. So that's the end of the presentation. In this particular presentation, I didn't want to talk about the technology a lot. I want to talk about the concept. So since this is a new topic even for all the subjects, so if there are any questions, I'm happy to.
Chamika, is this micro front-end framework support SSR as well to SEO optimizations?
Yes, I mean, what micro frontend does is just linking these together, right? So if you are using it, all depends on what you use inside to build these individual micro frontend. If you are using React, if React is supporting all these stuff, then yeah.
So that the server-side rendering and those kind of will happen in the application shell, right? So that
Server-side rendering is something else. Now, this
yeah.
approach is not.
Yes. Okay, component-wise we can do, right? Okay. Yes, good.
Yeah.
So, Chamika, are there many micro front-end JavaScript frameworks, or like
Yes.
are there like well-established frameworks? Yeah.
Yes. The one that I'm using for this particular presentation is called Pyral. It is developed on top of React. So if your micro front-end solution has a great tendency towards towards React, that is, if most of the front ends are being developed using React, I think this is a good solution. But apart from this, there's one other framework called Single SPA. it is not based on React or any other framework. It's based on a standalone framework, so it can be used as well. And even if you take the Spiral, it supports all the other most of the other popular frameworks as well. React, Vue, Aurelia, even Blazor is supported. Blazor WebAssembly is also supported. So yeah, you can use this with other frameworks as well, other than React. And yes, you have several other micro front-end technologies in the market at the moment.
That's very good. I think another side benefit you might get if in a large project you use it, and then let's say due to technical debts, you want to upgrade your tech. Let's say you want to upgrade from React 2 to 3 or whatever version upgrade, or if you want to change the technology stack from React to Blazor, let's say. So probably you will be able to do that component wise without without the users feeling about it or taking a long time to do a big huge refactoring throughout the application, right? That's
Yes.
also an added benefit.
Yes, exactly. You can do. I mean, that is one of the advantages as well. You can do upgrades and various other stuff component. I mean, micro front ends level. Yes.
Good.
Yeah, that's it, guys. Thanks for listening.